Hello, welcome. My name is Megan. I'm one of the instructional assistants that works in the Academic Supports Math Center on the Lee campus. Today, I want to talk about some rules about logarithms. In particular, after I go over these general rules, I'd like to do some examples of condensing and expanding them. Now, logs are going to be particularly helpful once you get to certain courses. I find that mastering these rules now will really help you in some of your future work. So first things first, let's actually go over some rules when it comes to the exponentials. So when it comes to your exponents, the following rules apply. Whenever you see something like x to the second times x to the fifth, that shows that really you add the exponents. So it's really like saying x to the 7. Your next problem, if you had something like x to the fifth, and you were dividing it by x to the second, you would subtract the exponents. So in this case, x to the third. Whenever your variable's power is external like this, you're multiplying them. So 2 times 5, it'd be x to the 10. Alternatively, if you have a fraction exponent, like perhaps you have x to a 3 halves, well, we're actually going to set up both a radical and a power. The denominator goes here, and the numerator goes here. But it should be noted, whenever that radical has a 2, that's your standard square root, so you can write it like so. And then finally, whenever your exponent is negative, it can become positive by changing its position on a fraction. So if it's a normal value like that, put it in the denominator like so, and you now have a positive exponent. I just wanted to bring up these rules because they're going to help us with some of the stuff we'll be doing later. There we go. So I first also want to go over the logarithmic form versus the exponential form. Now you might sometimes have something in one form that would be better written in another form. Converting between the two is not too bad. You just need to identify which parts go where, and then those same things go on the other side. So like as you see here, log base b m equals y, that same b is used in both places here. That y goes here, and that m goes here. So let's say you have something like log base 8 x equals 64. So that would be like if we wanted to convert it, 8 to the 64 equals x. And that would be a very big number, but the point is we can convert between the two. Now let's go over some properties of logarithms. In many ways, you can say this relates pretty well to those exponentials that we were just looking at. But often you'll be asked to work with logarithms, so it's really important to know these rules. So keep all these in mind and feel free to pause at this point if you need to take notes on these rules, because we'll be using them to help us with the next two problems. Here we go. So for our first example, we want to expand this log as far as we can. And there's going to be quite a few steps to what we're doing here. So the first thing I personally like to do is check if there's any fraction occurring. And there does seem to be happening. There does happen to be one right here. So when I write this, I'm going to employ the rule that whenever log base b has a fraction, this is the same as your log being subtracted. So we'll be doing that part first. So we have log base 3 of your first term, which would be everything in the numerator, minus the log base b of everything in your denominator, like so. So that's our step 1. The next part I like to do is look to see if there's any products being multiplied together. Because remember, whenever they're being multiplied, we can add the two logs when they're separate. So I'll be doing that here. We have log base 3 of 81 plus log base b of x squared minus. Now this minus applies to everything in the denominator. So I recommend having a parenthesis out here to show the minus still applies to it all. And we have our log base b of y to the 4th and our log base b, base 3. Yep, that's a silly mistake. Let me just erase that. Sorry about that. It's easy to lose track of your terms, huh? There we go. Our next step is to check the powers of what we have. So I want to put everything in a most simplified exponential form. When I look at my 81, I can actually rewrite that as 3 to some power. In this case, 81 is the same as 3 to the 4th. And I want to see powers of 3 due to the fact that I have a base of 3, because I will be using that log base b whenever this matches the same as the base. It simplifies to whatever your exponent is. So if 81 is the same as 3 to the 4th, that means this entire first part is now just a 4. Additionally, I'm also going to use the rule that whenever you have an exponent, you can move that exponent in front. So I'll be doing that as well. Since x squared, that means an exponent of 2, I'm going to place that 2 in front. This log has an exponent of 4, and this z, recall that whenever you have a radical, you can write it as an exponent fraction. So that means I'll put a 1/5 in front of that term, giving us a 2 log base 3 of x. And we also have this minus sign in front, so we might as well distribute that. So we have a minus 4 log base 3 of y minus 1/5 log base 3 of z. So there are a lot of different logarithm rules which can all be used even within the same problem. So it is definitely good to practice those rules and have them known for whenever you're dealing with logs in your classes. Now let's look at a problem that's actually an exact opposite of what we just did. Instead of expanding our log, we want to see if we can condense a log. So we're going to try to put this all into one term. When I work in this order, last time the final step I did was putting all those exponents in front, and I'm going to work in a reverse order here. So I'm going to put all those exponents up. So I begin by taking each coefficient in the front and putting it as an exponent. So this one, since the coefficient front is 2, it's going to be log base 2 of 3 squared. Our next term, we have log base 2. And instead of saying x to the 1/3 power, remember that a fraction exponent is really just a radical. So I can write it like so. And then our next one is log base 2 of y to the 4th. And there's no coefficient in front of our last one, so we can keep that one as is. From here, I noticed that our two end terms here have a y negative in common. So I'm going to factor that negative out. Rewriting, we have log base 2 and 3 squared. It's fine for me to just write it as a 9. And now I'm going to take that common negative out, leaving log base 2 y to the 4th plus log base 2 z. Now at this point, I notice that we have a couple terms being added together. So this is where we can use that the log of m plus the log of n is the same as 1 log with them being multiplied together. So I'll be doing that for both groups. We have log base 2, and then we have 9 times cube root x minus log base 2 of y to the 4th times z. So now my final step is to look at whenever you're subtracting logs, this is the same as dividing them as one term. So I'll be doing that here. We'll have my first term as the numerator, and since we're minusing it by the second term, that's your denominator. So our final solution is log base 2, and then your numerator is 9 times the cube root of x, all divided by y to the 4th times z. So that is a fully condensed logarithm. So thank you for sticking around for this video. If you have any other questions, whether it is on logs or anything else in your class, feel free to schedule a tutoring appointment with the Academic Supports Math Center. We offer individual tutoring, but we also have a walk-in basis. Just feel free to look for more details on our site. And thank you again. Have a good one.